Hello, ladies and gents. Welcome. Welcome to another episode of ML for Noobs. Now, there's two things I should probably address at the beginning of this episode. One is, I said there was not going to be any more videos related to Lesson 1, and this video is actually going to be about Lesson 1. And what I'd like to do is, in the last video, I noticed that I was kind of shying away from actually seeing the source code. There were a few commands that I wasn't really familiar with, and yeah, so I didn't actually go into that, the source code to see exactly how the functions worked. And so that's something we're going to do right now. So we're actually going to look at the functions that we used in the practice exercise and figure out exactly what they did, what parameters they take, and how we can make them work. And the second thing you may be wondering about is what happened to your accent. Well, I can't really explain why I'm using a British accent right now, but I'm really feeling it, you know what I'm saying? I'm just really feeling that British accent, and so hence this video is going to be conducted in a British accent. And if you have any problem with that, then deal with it. Alright, so onwards, let us begin. Now, to get started, I've SSH'd into my GCP console, and that's what you're seeing right now, and I should be able to access it at localhost, I think it was 8080, was it? Alright, let's take a look. There we go. Yes, definitely 8080. It's going to take a bit of time to set up. Now, what I'm going to do in this video is very simple. What I'm going to do is I'm going to take a look at the source code and take a look at the last practice exercise that we did. And within this exercise, I'd like to figure out, alright, Python 3, yeah, tutorials, FastAI, Course V3, NBS, DR1. We're going to Lesson 1 practice. That's the notebook we're interested in taking a look at. And so what I'm going to do is I'm going to take a look at this notebook and all of the functions that I found confusing, all of the things that I didn't really understand. We're going to dive into the source code. All right, we're going to go hacker style. We're going to figure out exactly what those functions do, and if there's any sort of problem, we're going to try and figure out how we can avoid that problem sort of recurring. And so this does look a bit different. The last one I was looking at, it actually truncate the output and add some sort of drop down here so I could see how it's working. This looks a bit different. View. Can I make it view? Presentation, single document mode, is that it? Which I can't see what's wrong here. That does look different. Presentation mode, could it be? I don't know what's going on. Name error. Well, anyway. Yeah, I can't really see what's going on. Open tabs. I don't know what's going on. This looks different. The last one I actually had browse taking up the whole screen, and then when you double click, it just opens it in a new window. Not really sure what's going on here. Anyway, I'm not going to sit and obsess over this. We're going to go through the same process, and whenever we have something that looks confusing, we are going to make sure that it gets addressed. So I'm going to go to .fastai/data, and here we had downloaded the dataset before. I'm going to remove dataset. Alright, that's removed. And now we're just going to execute these instructions. So path is download data, blah blah. That's doing its thing right now. Is it downloaded? Let's take a look. There it is. Gender detection face.tgz. Well, that's actually not what you're looking for. The extension was zip, if I recall. Alright. Much better. So that's 68 megabytes. Alright, so let's just remove the .tgz. Alright, and then we continue. So unzip. it's doing its thing. See, I don't know, it used to truncate the output, now it's just showing everything. Anyway, path image, we'll set that. And now we'll do get image files, fnames 5, and you can see that that's working. Let's see if image data bunch is going to show us what we need to see. And then let's get a preview, see if that works. Now, what we're expecting is man, woman, a bunch of images, and they should be properly labeled. So let's see if that works. It's doing its thing. How do you hide this? It's taking up way too much space. Alright, so I can see that that's working. You can see everything is properly labeled. Oh my god, what happened to that man? His face looks like a blob. But anyway. Fortunately, that's not what our face looks like, is it? Anyway, alright, so let's get to business. CNN Learner. Alright, now this bad boy is just taking data and alright, it's creating this learn object that we then convert into a model, and then we call fit one cycle. Right, that's what it's doing. Now I'd like to understand, what is it actually doing when it does this fit one cycle? What's actually going on? All right, so let's take a look at that. And so we do A. All right, so we're gonna insert a line before, and here we're gonna do just like we did before. We're gonna do learn.fit one cycle, and what this is gonna do is it's gonna show us the documentation. All right, what we're really interested in. All right, so this tells us, all right, it's going to take a learn, and that's what it's taking when you call, well, learn.fit one cycle. It passes learn, which is the object, as the first parameter. And it takes a bunch of stuff as well. And these are, I guess, for the large part, optional. And we've already seen how slice works in the past, and there's also a bunch of stuff that you can do in order to modify how it actually works. But what I'm particularly interested in is the source. So we're going to go ahead and click on the source. And this is where things get interesting. All right, stay with me here. Let's dive into the source and figure out how this actually works. Like, what is actually going on under the hood? All right. So when you call fit one cycle, it takes a learner. Great. I don't know what a learner is, but we're going to find out. And then it says, all right, max LR. We've already seen that before. That's the max learning rate. It takes like a slice of floats, so either floats or slice. Okay, and then fit a model following the one cycle policy. All right, cool, whatever that means. Learn.lr underscore range max LR. All right, so it's doing something with max LR. And then listify callbacks, and then callbacks.append one cycle scheduler learn max L. All right, and then learn.fit. Okay, so this looks like the main function. This learn.fit is where the action is. So let's see if we can figure out where that learn.fit function is. So learn.fit, where do we find that? Okay, so we're in train.py. Let's see if we can find learn.py, because that's the learner. Is it learner.py? Old fast AI. Fast AI. Old fast AI. Oh. Where could it be? Docs. Okay, so there's text learner and there's vision learner. So I assume we're going to be vision learner. Again, remember, what we're interested in is, where is the source? Vision learner.py, and we're interested in .fit. So define fit. I can't find that. Interesting. Oh, yeah, you know what? It's actually going to be a lot easier to browse the source code if we just clone this whole thing. So let's go ahead and do that. So we don't need it in the data directory though. Let's see if we can just, well, actually it doesn't even need to be in that directory. So let's go ahead and just put it in the projects directory. And so I'm just going to do a git clone, and and I'm going to call this fast AI SRC. And the whole idea, again, is we're going to browse the source code and see if we can figure out how things work under the hood. So we got to the point where we're seeing learn.fit. Let's see if we can go back to where we saw that. All right, here it is, learn.fit. That's where it appears to be doing the majority of the work, all right? And so we're going to dive into that, figure out exactly what's going on under the hood. All right, I feel like I keep sort of drifting into the British accent and drifting out, so I need to deliberately focus on implementing this British accent to the maximum possible extent. Oh, excuse me. All right, still working. 18%. This is pretty slow, isn't it? It is. All right, let's give that some time. All right, so what's this one cycle scheduler? I wonder. Let's see if we can learn more about this. All right, one cycle scheduler. Here it is. Instantiate a one cycle scheduler with LR max. Return partial one cycle scheduler. LR max keyword arguments. Okay, I have no idea what that is. But is it this? Like, is it the same thing? One cycle scheduler. Yeah, it's all the references there. Learn.fit. Maybe it's in this directory here. Do you see learn here? Learn. Oh, learner. No, I don't. Maybe it's in core. Fit. Define fit. No, I don't see it. Alright, let's wait for this. I'm just gonna go ahead and pause until this is done. Alright, folks. Finally done downloading all these files. So everything, now we're ready to inspect the code. So I'm just gonna fire up Visual Studio Code and let's take a look at how this actually works. So, alright, what are we doing? Okay, don't need that. Right. By the way, I managed to figure this out. You have to hit localhost 8080/tree to get the full screen view. I was looking at /lab. Anyway, so we're looking at this code over here, and what we're gonna do is we're gonna search. We're gonna do a file search, and we were looking for fit. That was a function we're trying to figure out. So basic train. I can see more than one option here. All right, so I can see this fits a model. All right, so this is the one that we were, so fit one cycle, this is the one that we were looking at. And we noticed that it calls learn.fit. Now the question is, where is learn.fit? Where is it coming from? So we can see that from basic_data and basic train, we're importing a bunch of stuff. So this should either come from basic train or basic data, right? So you can see basic train has defined fit right here. All right, so could this be it? LR, WD, and callbacks. Is that what we're looking at? LR, WD, and callbacks. Sure looks like it. All right, ladies and gentlemen, I think we found a culprit. All right, so fit, what's going on? What are you doing? So you can see learning rate, if WD is none, WD equals self.w, I don't know what that is. And then self.opt.lr, just trying to figure out the learning rate in WD's weight decay. All right, and then it calls fit epochs. So let's see what's going on here. So define fit the model. Fit the model on data and learn using loss function and opt. Okay, so it's calling CB handler, callback handler, dot on train begin epochs blah blah. All right, and then it says for epoch in pbar learn dot model dot train. Okay, for epoch in pbar learn dot model dot train. Now I was hoping to figure out where it's actually getting these images from, because that's still a black box to me. Like, is it actually using the directory structure that we have over here, right? Because my concern was when you hit data and you go to data set, right? Here you can see that there's models, test, train, and valid. Now I want to make sure that it's only training on the train directory, right? You make sure that's happening, because if it's training on stuff outside of the train directory, then you have a problem. It should be training only on the stuff in train. So somewhere in here, you should see some sort of reference to train. Anyway, so let's see what's going on with learn.model.train. Let's see what's going on here. There's model, and then .module. Okay. Okay, that doesn't really say much. What if we searched for train dir in there? Huh, that would be details, test vision. Oh yeah. Okay, test vision data. Train valid classes, test vision datasets. This is okay. These are test libs. Data test images, test vision pill to I don't know what's going on here. Anyway, so fit the model on data. Alright. On train begin. Let's see if we can see where that's defined. Okay, camel to snake, blah blah, self blah blah. Okay, for CB, jump to epoch. Okay, nothing interesting there. Yeah, I can't really see anything going on here. This is on train begin. So fit calls on train begin. On train begin calls jump to epoch. Callback.py. Kind of lost. I don't follow the code here. Like, what is going on? This is confusing. This is confusing. So we started, let's take stock of where we're at, right? We started at this point over here, right? We were looking at what? We were looking at this. Learn is CNN learner. Okay. So let's see if we can find. All right, let's start there. Let's start CNN learner. See what's going on. All right, blah blah blah. Basic train callbacks. All right, let's see where. Define CNN learner. All right, that's where we are. Build convnet style learner. Okay. Create CNN model, blah blah, learn.split, split on meta split. If pre-trained learn.freeze. Okay, so pre-trained bool is true, so it just assumes that it's pre-trained already. Interesting. So just to make sure we're looking at the same thing, what we'll do is we'll do doc CNN learner and make sure we see this in the source code, data punch. Yeah, it's definitely the same thing. We're definitely looking at the same thing, right? Excellent. So we know we're on the right path. So this is what we're looking at, and it calls creates init model, all right? So creates a model, that's fine. Learner, okay, all right, this is interesting. Learn equals learner, data model, keyword arguments. So learner, there's something going on there. Let's click on learner. Let's see if we can dive into learner a little bit. It says trainer for model using data to minimize loss function with optimizer opt_func. Okay, so data model keyword arguments are all passed to learner. So I assume learner is doing something interesting. So let's see if we can figure out what it's doing with data. So it says data is a data bunch. Interesting. Bind, train, valid, and test DL in a data object. Okay, click on that. So when you call init, bind train DL, valid DL, and test DL in a data object. So you have init train DL, valid DL, data loader equals null. I feel like we're getting somewhere here. You see these three things look very familiar. Train, DL, so train, valid, and test are all folders in this little folder that we have train, valid, and test. Train, valid, and test. Sound familiar? Excellent. If it does, because it's what we're looking at right here. So it seems like we're on to something here. Anyway, so it says data is data bunch and post init. All right, so what's going on here? Let's see. Learner, data, model, keyword arguments. All right, so what's happening is learner is doing something with this data. So we can see that when you call init, it simply calls apply init. And what does apply init do? Initialize all non-batch norm, blah, blah, apply leaf and partial. Okay, I have no idea what that is. But apply leaf, apply f to children of m if instance m and then dot module fm for ln apply leaf lf. All right, so it's applying f. F is a layer function. Apply leaf. All right, I think that's something else though. Seems to be something that you touch code. Wait. This is torch. All right, I'm gonna go into the torch source code. All I'm trying to do is figure out what's going on here. So when you call apply init, we're hitting torch source code. All right, so is this the torch repository? No, this is not torch. This is basic train in the FastAI lib. All right, so you call init self init. Wait, is that, how does Python work? Like, where's the constructor? Is there a constructor here? Is it an init? Learn callback base class for creating callbacks. All right, you can see callback. Load callback. No, we're interested in the basic learner class. So basic learner class has a fit function, which we're looking at here. At data class. Where am I? I feel kind of lost. All right. What we did is we went to learner, passed data. So what we're interested in is the learner class. So let's look for learner. Class learner, that's this. And then it has define post init. It has define init, define test, blah, blah. All right, you know what? Let's figure out what's going on here. So Python constructor method. I don't know what the constructor method is for Python. So let's take a look at that. And okay, What is the construct? All right. It's init. It's init. The constructor method is init. So if there is an init method here, then we're on to something. All right. So let's see. Class learner. Where are you? Class learner. Does it have an init method? Is it inheriting from anything? No, it's not. Does it have an init method? I see init, but not underscore underscore init underscore underscore. So I don't see that. Okay, doesn't seem like it has a default constructor, which is interesting. But it has post init. What is this post init? Post init. Okay. I don't know what that is. Post init. The newly returned created by calling the init method. This ensures that post init, if present, is also called. It's part of this data class thing. What is a data class? Okay, I feel like I'm going down a rabbit hole here. What on earth is a data class? Data classes dot py. Python data class. What is that? Is a data class. A data class is a class typically containing mainly data, although there isn't really any restrictions. It's created using the new data class decorator. Yeah, that's what I saw over there. All right, so data class comes with basic functionality already implemented. For instance, you can instantiate, print, and compare data class instances straight out of the box. All right, so that explains why. That explains why you didn't have an init function, because this is a data class, as you can see up here. So init, all of the parameters that you're passing here, data, model, keyword arguments, are actually getting initiated directly. So data is automatically assigned, model, and the rest of the arguments, I guess, too. And so data is automatically set. And data is part of this data bunch. And then clicking on data bunch takes us to what this basic data thing is. Okay, so it automatically sets this up as a data thing, or called a data bunch. And then in here, it's setting self.trainDL, self.validDL, fixedDL, and testDL equals map, createDL, and then all the other stuff. And so if we take a look at that, if DL is none, return none, else return device data loader. Bind a data loader to torch device. What's going on here? All right, list callable, blah blah. Okay. Yeah, I'm not really sure what's going on here, but I assume it's gonna access the directory somehow. A new copy of self. Class method create. Data loader. Bind data loader to a torch device. Alright, so what's this data loader thing? I just want to understand. Okay, so a data loader is a torch thing. All right, so data loader is a torch thing. And so when you call create DL, it's creating a, so when you call create DL, it's creating a device data loader for every single one of these: train DL, valid DL, fixed DL, and test DL. Okay, and this device data loader is a torch thing. Device data loader. So you can see that from import default collate. Default collate. Okay. All right. I'm not really sure what's going on here, but I'm just going to take this at face value. So it says it's binding train, valid, and test DL in a data object. So I'm just going to assume that it's doing all this stuff, right? So when it says grab dataset self.train DL, I'm just going to assume that means that it's actually pulling this information directly from a train directory, right? And so that's what's going on, right? I don't know how. I don't know how it's working with Torch, but I really don't want this to go really deep, right? I just want to make sure that it was actually doing this, and it seems like it is. So it's clear that when we run this bad boy here, so when we say, let's go ahead and run all these again. I don't think it's from fast AI. Right, so renew. Oh, I don't need to download all of that again. Alright, so let's just get it here. Alright, random seed, data bunch, show me a batch. Just make sure that's working. Alright, there we go. Woman, man. Yeah, looks about right. And then man, woman, and it looks good. And then when you initiate CNN Learner, so CNN Learner is where we started, right? We dove into CNN Learner, and it looks like it's taking data and then parsing all of the different train, test, valid, blah, blah. And then when you call fit one cycle is using the learner in order to do the actual iteration. So when you call fit one cycle, it's also taking into consideration the fact that, yeah, all of this stuff is segregated, and that's what I wanted to make sure of. So with that said, let's start this learning again. I don't know if this is gonna work or not, but we'll see. And yeah. Let's see if we actually get the sort of results that we expect. So 10% error rate, training loss, valid loss. Okay, training loss is significantly higher than valid loss. Not really sure what that means. And then it gets lower. I suppose as long as all of them are getting lower, we're kind of okay. We're getting about 7% here. Okay. Learn dot. So let's go ahead and learn dot save. Let's see what results we've got. Let's see what the top losses look like. Okay, top losses. That's what we're looking at. So the prediction was man is actually a woman. Whoa, what? Actual was woman? That can't be right. That can't be right. This is not. Okay, there's something wrong here. Huh. The actual predicted as a woman, the actual is a man. Alright, that makes sense. Predicted as a man, the actual is a woman. That makes sense. But predicted as a man and then the actual is a woman? This is not a woman. This is weird. Which image is this? See if we can copy image location and open it up. Oh, okay, there's a fixed image. Can't really see. That's very interesting. I'd like to see which image that actually is, and if it's properly labeled or not. Is it a labeling issue, or is it an issue with? I mean, the others seem okay. This is a woman. That's a woman. That's a woman. This is a man. It's a woman. That's a woman. Yeah, it seems okay. Okay, the confusion matrix. What's going on here? Alright. So there's a predicted 27 is men, but they're actually women. Predicted 9 is, well, woman. Predicted 9 is men, but they're no. Predicted 9 is woman, but they're actually men. So I'm less confused. Right, it's definitely confusing more. Woman for men. So predicted. So 27 women were predicted as men. Interesting. So let's see what happens with PG over here. Let's learn.predict. Now it predicts it as a man. This is definitely different from what it did before. In the last video I showed you that it predicted him as a woman. I'm not really sure why it worked this time. Let's see if we can dive into learn.predict and see what's going on here, shall we? Alright. So let's go ahead and insert cell above and do doc learn.predict. What's going on here? Okay, that's it. Learner.predict. Source. FastAI basic train.py. Basic train. Define predict. Let's see. Here we are. Return predicted class label and property and probabilities for item. Dot whatever. Okay, so item is whatever it is that we're actually passing. So self.data.one item self.predict batch equals batch, which is that one item. Grab IDX batch equals first. Get adder self data norm if norm self normalized denormalize. Okay, it's done a bunch of stuff, and then y.analyze prediction and spread, and so it returns predictions, raw prediction. So return xy, or returns y. Return x is false by default, so it just returns y prediction and raw prediction. Y prediction and raw prediction. So we're seeing y prediction, raw prediction. Prediction and raw prediction. Well, what is raw prediction? Grab IDX. Okay, let's go down that rabbit hole. Grab the ith batch and x batch first, starting the batch dimension. Okay, that's part of torch. Grab IDX, huh? Res 0 batch first, batch 0. Grab the ith batch in x batch first, stating the batch dimension. Okay, I have absolutely no idea what that is, but I guess it has something to do with probabilities. And alright, so bottom line is actually it does look like it's predicting properly now. I wish there was some sort of measure that I could use. So there's some sort of mistake with some of the data, and I'm not really sure how I could dive in to figure out if this is okay or not. If there's actually a way to see what the data looks like where these images are actually coming from. That'd be very interesting, just to see, not plot top losses, but retrieve top losses. Maybe we could just search top losses and see if we can find top losses. Can we just use top losses? Doc dot top losses. Does that exist? Huh, okay. Alright, let's just run this then. Interrupt dot top losses, show me. Alright, so it's returning some sort of object. Values equals tensors. Okay, so it's just returning a bunch of bound method classification interpret and top losses object. Self.losses.2pk sorted by largest. Top K. So it's returning a bunch of losses. Returns tuple of losses and indices. Maybe these are the indices of the actual file. Wait, why can't I? Let's run this on 9. Is this it? 325, is that the index? Let's see. So we go to train. We want face underscore 325. Can we see that? Oh, okay. You can't open the file. How do I access this file? How do I view this file? Face 325. Let's see. I think I've actually got this downloaded. And so if I unzip, is it face gender detection? And so if I unzip that, then I should be able to just open it directly. Alright, that's a lot of files. Okay, so face 325. So if that's face 325, what you are interested in is the second one, which is face 158. Does this always return the same? Yeah, okay, so they're sorted by largest. So face 158. That's the one I'm interested in. So let's take a look. Alright, so find data set dash name face 158.jpg. Where are you? Alright, so we've got, there's a face 158 in man, and there's a face 158 in woman. Now we're getting somewhere. See if we can find. Okay, this doesn't work here. That's where we are. So let's go ahead and go to test. Not test, not train. So face underscore 158. Give it to me. Well, come on. There it is. That is not the file we're looking at. Is that one of them though? Yeah, that's this one over here. That's this one. Okay. So that was that one there. Well, are these actually arranged somehow? Now let me just take a look at the next one. 325. Are you there? No. 289. 249. It's not him. 409. Why are these non-existent? Huh. Oh, because it's a woman. Okay. So since the actual is a woman, what you want to be looking at is the woman dir. So let's go ahead and explore the woman directory. So we'll go to test woman, and here we should be able to find the files that we were looking for. So 325 underscore, that should show up. Okay, that's not showing up. Huh. Where's that? Valid. Huh. Is it using the valid directory? I have no idea. What is the valid directory anyway? No clue. Alright. Anyway, so what's clear here is that it's sorted by the largest, right? So 5.51, so by loss, right? It's sorted by the largest loss. What's going on here? All right, so we should be able to see top losses, largest equals largest, and largest by default is true. Can't is 9. So when I select the top 9 by losses, it's returning the top 9, and so as a result, this is the second, which is 158. So I really just want to find face 158 and see where we are. Now I checked it, and 158 is in the man directory. So test man. Okay, so there's test man face 158, but there's also test woman face 158. So let's take a look at. Huh. Yeah, that's not our suspect. So the outcome is that this is a woman. We know that it thinks that this is a woman. 325. There's no 325. Test woman. One 158 in man. That's this guy here. Alright, I'm not really sure what to do, like how this is actually set up. I mean, it's giving you, what does it call? What does it call that? Okay, it's giving you largest, smallest losses, and Indices. Okay. It's returning an index, but it doesn't necessarily mean that this index. I don't know how you can find the image at a particular index. Maybe it's worth a shot. Plots. Index. Yeah, I'm not really sure. Not really sure how you can retrieve an image at a particular index. Data.py, index of the text. Display? What is that? Show results. Alright, anyway, I'm not really sure what's going on here, and this video has already gone on long enough, but I hope that I've actually given you a sense for how we can navigate the source code. There's obviously a lot that I don't understand, but the whole idea is to be able to take a look and see, if certain things work the way you'd expect. We're able to find out that, okay, when you call CNN Learner and you pass data, that it's actually parsing the various directories properly, so that's good. And we also know that there's a problem here, and we were able to retrieve the top losses, but I really don't know how to actually access the proper index to see what the image will look like. And so we can see here that it thinks that, what is it? Who's this guy? Robert Downey Jr.? Mr. Iron Man here is a woman, but I'm not really sure why it thinks that. And so, yeah, maybe it's mislabeled data. Maybe that would explain why. But anyway, that's it for now. We're going to dive into the rest of the video. So lesson 1 lesson 2 is what we're going to be doing next. And, oh wait, isn't I supposed to be speaking in a British accent in this video? Oh dear, I'm so sorry. I somehow slipped back into the regular accent, unfortunately. So it is going to take quite a bit of practice, and so for that I apologize. Anyway, for now, this is it, me signing out. Adios.